So look here, now this one got executed. We can see the output here, grid search CV. And here itself, we can see that the whatever the values, the parameters are of grid, the grid we created. So what are the values we defined as part of this grid, or were used here? We can see that the grid search CV cross validation. Okay, it did the cross validation 5 times. See, in that case, what happens? It created 50 trees, and then it used 5 folds. In each fold, I see each fold the same model. So the same model ran in each fold, and then each fold, what is the this one, what is the, in this case it is ROCs, right? What is the AUC? Okay, and then it checks each fold what is the AUC. You remember the K fold cross version, 10 fold cross version explained you. So basically 5 iterations for each set of values, right? Each values it would run for 5 iterations. Here 5 iterations, and in each fold, it used let's say 5 fold, right? Each fold, the random forest algorithm used 50 trees each fold. Okay, and then again it created the 5 fold cross validation, 5 folds, and each fold it used 100. That's why it took this much of time. And then the next one is, if you see here the best params. See, this is my RF grid CV fit. Already we fitted. Okay, it took this much of time. And then the same thing, RF grid CV dot best params. If you give, and you can see the optimal values that needs to be used for these parameters. This is recommended by the grid CV. So it tells us use bootstrap equal to true, max depth none, you can use it, and don't specify anything here. And you can use square root, and minimum samples leaf you should have one, and number of estimates 50. And of these options, see, we have asked, it's something like, hey, can you please tell me how many number of trees can I use it for this parameter? And how many minimum sample per leaf should I use it? So likewise, it suggests as, so you can use these values. These are the optimal values. Minimum samples, leave random state out of the true, and it's okay. So this is what it gives us. And the next one is or of grid CV. If you press tab here, it will show you all the options here. The important option is best estimator. It gives us this one. Okay, best estimator, best model. So it created so many models, right? So the first one, for the first one it used 50 trees, and again 5 iterations it performed because 5 folds. And next it used 100 trees, and then it performed 5 iterations. So now you tell me what are the optimal values for the params. We can see that, and give me the model as it is. So simply you can copy paste it, and then you can use it. So what we do is okay, this one is the this model. You go and check it, okay, and the accuracy. What is the accuracy that you are getting it? The next step is you go ahead and deploy it in production. Okay, we don't do it directly, but still, right? So there are some other steps are there. So, but this is the one. So your model is fit for deployment. Okay, with these values. Next one is to try with the reduced model. So in this case, I have used all the independent variables. We did not do any feature selection. Yes, I dropped 4 variables columns that were having multicollinearity, and but still, based on the features recommended by random forest model, we can try it out. So these are the feature importances. They'll ask you how do you find out the best set of features, so the subset of the features, or how did you do the feature selection? You can tell I have used random forest, or you can tell XGBoost. Even using XGBoost, we can find out uh, the features that were having higher predictive power. So in this case, the taller bars, if you can include only these variables, it will be helpful. The rest of them are not much helpful. You can try it out. Okay, you can try all the things. So anyhow, we will take a look at the XG Boost a little later. We will come back later. I just